Another common experiment is rolling a six-sided die. So the first experiment that we saw was tossing a coin. A coin has two sides, the tails or heads. A die usually has six sides. So the outcomes can be 1, 2, 3, 4, 5, or 6, and the result is the number of dots facing up. We also have that more than one die is called a dice. So one die, two dice. Let's take a look at question number 2. You roll a six-sided die. So remember, this is the prompt you're getting. And then next, you should think of, what is the experiment? What am I dealing with? What's the action? Am I dealing with a coin, a spinner, a die, cards? What am I doing? So the experiment is the action. And so let's say the experiment is rolling a six-sided die. That's the action. You're going to roll a six-sided die. Let's draw a tree diagram. As always, I start you off with me. Here's me. Here's my little die. I'm going to toss it, and what can happen? I can toss. When I toss it, it can be a 1, it can be a 2, it can be a 3, 4, 5, or 6. That is my tree diagram. Let's go ahead and list all our outcomes. Our outcomes are, you can put it in a sentence. One of the math symbols you'll usually see is a squiggly bracket. So we have 1, 2, 3, 4, 5, 6. And so these are all our possible outcomes. Number 3, you roll 2 distinguishable six-sided dice. This is similar in experiment because we are still dealing with dice, but we see a major important thing is that it's 2 distinguishable. What is the experiment? The experiment is rolling 2 six-sided dice. Why is this so important and different from the first one? Is because it's going to give us a completely different picture and, in fact, a little messy. Let me remind you that from the problem above, we had just one, and you can see this is our tossing point, so this is our one toss, and so this one's going to be quite different. Of course, this is me, and here's my little die. Now we're going to do this twice, so here comes the first one. Here's going to be 1, 2, 3, 4, 5, 6. And I'm the type of person that likes to finish one thing at a time. So in this instance, you see my one toss and all of the outcomes for the one toss. You could be the type of person that draws like the 1 and then thinking moving forward without having the 2, 3, 4, 5, 6. You could start working on your next toss. But I don't do that. I do one toss and then here comes my second toss. Let's label this as die number 1. And here comes die number 2. So if my first die landed on a 1, I now pick up my second die, which is blue. It's distinguishable from the first one, which is pink. We're going to toss it, and that die could land on 1, 2, 3, 4, 5, or 6. You're going to see this is going to be messy, and it's going to take me a little bit of time. So let's extend number 2. And so on. Let me go ahead and number all of these. And here we have our tree diagram for two distinguishable six-sided dice. This is very different from a one toss, okay, which was on example number 2. So when you're reading your question, you have to determine, does my experiment require me to toss one die or two dice? Let's go ahead and list all of our outcomes. This is going to be lengthy and a little bit messy, just like our tree diagram. Why is it lengthy? I'm going to have to follow, if you were following paths, so this is the first path I would follow here, 1, 1, or remember at some point I talked about following branches. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36 things to list. Of course, I could have counted that way easier. You could have said 6 times 6 is 36. So many different ways to see things. Let's go ahead and get started on listing all the outcomes. First, my squigglies that signify this is a set, and then my pair. So I'm going to have 1, 1, 1, 2, and this is not an 11, so I'm going to put a small comma in between, but make sure I have plenty of space. I have 1, 3, 1, 4, and so I finished that first one with these little branches. Let's move on to my 2. If I tossed a 2 and then had these branches. And as you know, we're going to have quite a long list. Let's continue. This is your complete list of outcomes. So although this was very long, I find it very important to complete the tree diagram and the list of all outcomes with you, because this is a question that's asked very often in 1342. There is also another important way to list all of these outcomes. We're going to use a table. This is a different method compared to tree. I find the table in this case a little bit easier. Let's use die number 1 on top. Die 1 is going to give me the outcomes 1, 2, 3, 4, 5, and 6. And we have die number 2, and this die is going to go up and down. It's going to be 1, 2, 3, 4, 5, 6. So here we pair them. See, I have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and so on. You're going to see exactly the same thing we see in our outcomes. Yay. So the table is a comparable method to the tree diagram. This does not list your outcomes. So if the question was to list your outcomes, this is not an acceptable picture. You still have to go with the list of outcomes this way with a set. Great. So far we've covered coins, we've covered dice, and now you are going to try a spinner. So a spinner can be represented in different ways. You can look at colors. So for example, here I have red, blue, and yellow. That's spinner A. Or sometimes 1, 2, 3, 4. Sometimes your spinner can have letters, right? So it could be like A, B, C. The spinners can consist of different things. I want you to focus on spinner A and spinner B. They're going to be spun once only. So this is quite on the simpler end. I hate to say they're easy. I'm trying to stay away from the word easy, but they're a little bit simpler than the 2 dice. So go ahead and show us what is the experiment, draw a tree diagram, and list all the outcomes for 4 and 5. Another common experiment is a deck of cards. This is important because I know El Paso tends to be mixed with our culture, and so you might not be familiar with our cards. So let's dig into the cards, and then you're going to try the question on your own. It says choosing a card from a deck of cards. So we have a deck of cards, and this deck of cards has 52 things total, 52 cards total. And then what you're going to see is the outcome, right? So if I see the ace of clubs here, that's the outcome. The cards consist of 4 suits. Okay, so here's one suit. This is a suit. This is a suit. This is another suit. And this is another suit. What are the suits? So this is the suit of clubs. Then we see diamonds. We see hearts. And the last one is our spades. So we have 4 suits. Again, 1, 2, 3, 4. And then each suit consists of a 2, 3, 4, 5, 6, 7, 8, 9, 10, an ace, a jack, a king, and a queen. Some other outcomes include red. So we have red cards and we have black cards. We also have face cards. The face cards are jack, queen, and king. Okay, so very different types of questions that can be asked of you. So it's important to be familiar with a deck of cards. So here's this one. A card is drawn from a deck of cards. What is the experiment? And just list one outcome. There is so many different outcomes. Just list one card that you could grab from a deck of cards. Pick your favorite.